and an intercept of 1, that is going to be equal to answer A. Okay, here they're giving us next similar question. It says write an equation in slope-intercept form for the line with a slope of -1 passing through the point 4/3, 0. So we want to use point slope form here, and then we will transform it into slope-intercept. So point slope form once again is y minus y1 is equal to m times x minus x1. Okay, with m being the slope, y1 being the y coordinate, x1 being the x coordinate. So here we have y minus 0 is equal to -1 x minus 4/3. Okay, so would simplify this side, y minus 0 is going to stay. Okay, or we can just say that that's going to be equal to y. So y minus 0 is the same. There's no reason to isolate it. Using the distributive property here, -1 times x gives you a -1x. -1 times a -4/3 is equal to a positive 4/3. And we are in slope-intercept form here. So it looks like our answer should be D. And another thing that we could have done is if you just analyze the equations that we have, there's only one equation that has a -1 as a slope, and that is answer D. So you can answer this question without having to go through all of that work. Okay, what is the slope-intercept form of 4x plus 8y, which is equal to 11? Here, since they haven't given us a point, they haven't given us a slope, they've just given us an equation, and they say they want it in slope-intercept form. In order to get it in slope-intercept form, we have to isolate the y variable. Okay, this is what's known as a standard form of linear equation. You could actually plug this in to your graphing calculator and it would graph it for you, but they're asking for the answer in slope-intercept form. So like I said, we're going to isolate. So first thing, so we want to move the 4x to the other side. So we're going to be left with 8y is equal to a -4x plus 11. Then we want to divide by 8 on both sides. That is going to give us y is equal to a -1/2 plus 11/8. Okay, so that should correspond to answer C. Okay, for number 4, says write an equation. Share my screen again. Write an equation in slope-intercept form of a line that passes through the point 1, 1 and 0, 7. First step that we got to do is we got to run it through the slope formula, and I'll get rid of the change of screen here. And then we can plug it into point slope form. Okay, first thing, slope formula is y2 minus y1 over x2 minus x1. Okay, and remember, it doesn't matter which points we select as long as these are an ordered pair and these are an ordered pair. So I'm going to go 7 minus 6 or 7 minus 1 up, and then 0 minus 1 on the bottom. That gives me 6 over -1. So my slope is equal to a -6. Now I plug it into my point slope form. Y minus 7 is equal to negative 6 times x minus 0. Okay, so once again, simplifying it, distributive property on the right, negative 6 times x is negative 6x. Negative 6 times 0 is 0, so we can omit that. So after we carry out the distributive property, we're left with y minus 7 is equal to a negative 6. We isolate the y variable by adding 7 to both sides. And we are left as y is equal to a negative 6 plus 7. So that should correspond to answer B. And our last one, for our 5-minute check, it says a plumber charges a flat fee of $65 and an additional $35 per hour for a service call. Write an equation that represents the charge Y for a service for a call that lasts X hours. Okay, so whenever you're given a word problem like this and it says that it's going to charge a flat fee, that is your y-intercept. Okay, it's like a service call. It's just paid to him for showing up. So that is going to be your y-intercept. So we know, because if we do 0 hours of work, we still made $65. Then we want to find the equation that would have 65 as our y-intercept, and then 35 per hour. So $35 times x. So this should also be B. No, A. Why did I say B? A. Okay. The per hour is considered your slope or rate of change. Okay. And the $65 is our constant because he gets $65 just for showing up. And then $35 per hour after that. All righty. So we have written linear equations. Now we're going to talk about graphing linear inequalities and applying linear inequalities. Okay, so this breaks itself down to as simple as graphing a linear inequality is the same exact thing as graphing a linear equation, except for we're not going to have an equal sign, we're going to have an inequality sign. And then we will shade the answers that make it true. Okay, so we're going to have to do a lot of algebra to be able to get it into a form that we can work with and graph off of. So the new vocabulary, linear inequality. You have the boundary, that's the name of the line that we're going to be graphing. And then you have the constraint, which is the shaded section. And remember, we're going to shade what makes it true. Okay, so for the first one, graphing an inequality. Okay, in order to graph an inequality, we're given x minus 2y is less than 4. Okay, and we could actually plug this into a graphing calculator and it would be able to graph it and it would show it to us. Okay, but I'm so familiar with working with point slope form, I want to get this to where a y is separated, okay, or y is isolated. And all of my linear or solving inequality rules still apply. So the first step to isolating the y value is we want to get the x to the other side. Okay, so we're going to subtract x. We're going to be left with a negative 2y is less than a negative x plus 4. Okay, and then we're going to divide by 2 to finish off and isolate the y variable. So once I divide by 2, I have to switch my sign. So it is y, so in all reality it's y greater than a positive 1/2 x minus 2. Negative 1 divided by a negative 2 is a positive 1/2. Positive 4 divided by a negative 2 is a negative 2. Okay, so this tells me certain items. Okay, one is giving me a y-intercept. I have a negative 2, and I have a slope of a positive 1/2. So I come to my graph here. Okay, and in order to graph a line, we need at least 2 points. So the first point is very easy. It's the y-intercept at negative 2 or 0, negative 2. Okay, that's because when we plug in a 0 for x, 1/2 times 0 is going to be 0 minus 2, gives us negative 2. Okay, the next point that I'm going to use is I'm going to use 1. Okay, 1/2 times x is 1/2. Subtracted by negative 2 is a negative 1 and 1/2. Okay, which would fall right about there on my graph. And now I have all the information that I need to draw my line. Helps if I can get my thumb out of the way. Okay, so this is what my line looks like. Okay, understand that I'm not complete yet. I'm not complete. I want to pay attention to the symbol that I have. If it is just less than or greater than, my boundary line is dashed. Okay, showing that it cannot be equal to it. Similar to the same way we did interval notation, how we had a parentheses for the bounds that are not included. The dashed line on the graph shows that we're just dealing with greater than or less than. Okay, not greater than or equal to or less than or equal to. If we have a greater than or equal to, it would be a solid line. Okay, and the way that I kind of remember it is the line at the bottom of the greater than or equal to sign. I imagine that that line fills in these gaps. Okay, it's the way that I remember it. If I don't have that line, I have a dashed line. Okay, similarly to the way I have now. So I've got my boundary line drawn, but now I have to ask myself a constraint. Okay, what is it, this side or is it this side that makes my graph true? Because I want to circle in or shade in the points that make it true. And a couple things that there's multiple different ways to do this. I'm going to give you a check that works every time. Okay, so right now it's saying y is greater than. Whenever you see greater than, okay, it's typically talking about the top. Okay, typically talking about the top. So I have a good hunch that I'm going to be shading in everything that is above this line here. Okay, but what I can do is I can plug in a very easy point to work with and double check myself. The easy point is my origin point right here, 0, 0. And the reason that I want to plug in 0, 0 is because one, it's going to take care of all my multiplication. Anything multiplied by 0 is going to be 0. So I'm just left with my constant. And it's going to make it very clear. So I plug in a 0 for x and a 0 for y. And I'm left with a 0 is greater than negative 2. Okay, that's true. So that means that everything above this boundary line, if I were to plug it in, would make my inequality true. Okay, and I want to shade in all of the area that makes it nice and true. Okay, you can plug in multiple points. The hard part, or the only time that we're not able to plug in the point 0, 0, is when our boundary line that we drew from our linear equation crosses at the origin. Okay, if your y-intercept is 0, you cannot use the points 0, 0. But another simple, easy point to use would be like 1, 1 in that case, as long as it doesn't fall on the boundary line. Okay, because once again, 1 and 1, it makes your multiplication very simple, very easy to work with, and you can probably do it in your head most times. The quick way without plugging in points is you just realize that when it says y is greater than, you're talking about everything to the top. Okay, your y value is greater than. If it's less than, you're talking about everything beneath. Okay, and the slides, they actually graph it in standard form, and you can do that pretty simply with a graphing calculator or the Desmos app. So the boundary is a graph of x minus 2y, which is equal to 4. This is the inequality symbol is just less than, the boundary will be dashed. So there's their graph. Then they test 0, 0, plug it in, and you can see even when we plug it into the original inequality, it still works out. Okay, 0, 0 minus 2 times 0 is going to be less than 4, so it's true. And once we find that this is true, is when we would shade. Okay, and that's how we would present our answer. Okay, with the graph, with the shading being done. Nice. Okay, so it says which graph is the graph of 2x plus 5y is greater than 10. Okay, so the first thing with any multiple choice question that I like to think of, so I want to ask myself, are there some graphs that I can eliminate? Are there some answer options? Right? Process of elimination, if I'm able to do that correctly, chances of me getting it right go sky high. Okay, and looking at it, it looks like I can eliminate C and D because we have a greater than symbol and they have solid lines. We would only have solid lines if it's greater than or equal to. Okay, never if it's just greater than. So to finish this off, I'm just going to write it up. Plus 5y is greater than 10. Greater than 10 is they've already given me the graphs. Nothing changes within the graphs. They're the same boundary line. So really I just got to ask myself, am I shading below or am I shading up? Right? So they've graphed it for me. I just need to figure out what's true, what's not. So in order to do that, I'm going to plug in 0, 0 into 2x or into x and y, my coordinate points. So what that means is on this side, I'm going to have 2 times 0 plus 5 times 0. And if it's true, it's going to be greater than 10. 2 times 0 is 0. 5 times 0 is 0. 0 plus 0 is still 0. Is 0 greater than 10? That's false. So my origin is not a solution. Okay, it's a false statement. So looking between the graphs A and B, I'm going to be looking for the shaded region that does not encompass the origin, which will correspond to graph A. Here. Oh, wrong way. Okay, other ways, if you really fancy on graphing it, you can isolate the y variable to get it into slope-intercept form. Okay, making sure you abide by all your algebraic rules and your inequality rules, and then shade it from there. Remember, if you get it into slope-intercept form, if it's greater than or equal to, you shade the top. If it's less than or equal to, you shade the bottom. Okay. One tutoring company advises that it specializes in helping students who have a combined SAT verbal and math score of 900 or less. It says, write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X represent the verbal score and Y represent the math score. Okay, so they've distinguished our variables, and they are looking for students that have 900 or less. 900 or less. Okay, so they give us our whole as 900. Okay, and they give us X plus Y. And we're looking for areas where students that are beneath that. Okay? Okay, so it states that X is going to represent the verbal score. And if we add that to the math score, these two added together need to be less than 900. Okay, that in itself is our inequality. Okay, now we would just have to get it into a format where we would be able to graph that. Okay, and in order to do that, we would want to isolate the Y value to get it into slope-intercept form. Okay, so to isolate the Y value, I would subtract X from both sides. And if I rewrite my inequality, I have Y is less than or equal to a negative X plus 900. Okay, so 900 would be my Y-intercept. Negative X is my slope. So as I go 1 unit to the right, I need to go 1 unit down. My graph should be decreasing as I go left to right. And since it's Y less than, I'm going to be shading the underneath portion of this graph. Okay, shading the underneath portion. Here's their explanation. This is them setting up the inequality. So X plus Y are less than or equal to 900. And then you can see they're able to graph it in standard form. I always get it back in the slope-intercept form because that's what I'm most comfortable with, especially when they give me both. You can see my Y-intercept is still 900, okay? And I have a -1 as a slope. So I'm going to have the point 0,900, and then I'm going to have the point 900 here. Okay, does a student...
Mr. Burns, you keep freezing.
I keep freezing?
Yeah.
Okay, I'm gonna record it and post it on to Seesaw too. I can't really help if I'm freezing, but can they see where it says the answer now?
Yes, they can. You just got really glitchy for a minute there.
Okay. Yep. Okay. Well, we'll get through it. I don't really have any control over internet issues. So, once again, here's the graph.
I know.
We'll graph it in standard form. So we have a Y-intercept of 900. Okay, it has a -1 slope. So I have the points 0, 900, and then I have the point 900, 0 in terms of X and Y. And then it asks us, does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? So we would plug those into our inequality, take care of our addition there. 480 plus 410 is 890. Okay, so they would qualify in the shaded region. So we would answer, yes, this student fits the tutoring company's guidelines. Okay, last one. Class trip. 2 social studies classes are going on a field trip. The teachers have asked for parent volunteers to also go on a trip as chaperones. However, if there's only enough seating for 60 people on the bus, what is the inequality to describe the number of students and chaperones that can ride on the bus? S is chaperones, or S is students, C is chaperones. Okay, we have a max capacity, but we're looking for the inequality that states S plus C is less than or equal to 60, which corresponds to letter B. Okay, it's more or less whenever they give it to you in a word problem like this, we assign our variables. Since it's and, we add, and then we just need to be less than or equal to 60. Okay, it looks like I've had a couple people email me already. That's all right. I'll respond to your email as soon as I can. I am assigning the homework right now. Okay, it comes from page 36, and the numbers are 2 through 36 evens. But you also, it's Wednesday, so you also have your mastery check that needs to be completed by Monday at 8 a.m. Okay, and that should already be assigned in McGraw-Hill, similar to how we do it every week.